Hi guys, welcome to our last video in this computer lab session for Dr. Yan's class. In last videos, we've seen a two-tail test. We've seen a one-tail one side right tail test, and in this video, we're going to cover the one-side left tail test. And we're going to test whether the sensitivity is smaller than an arbitrary number, say 1.3. So essentially, we'll set the null hypothesis equals that the beta 2 is greater than 1.3 against the alternative hypothesis that the beta 2 is smaller than 1.3. And that's by having the test hypothesis value equals to 1.3 and then calculate the test statistic, and we can compute the critical value using the quantile function of the t distribution. The quantile function is given by q, and then the t distribution t, and then the first argument is the probability, and because we're tested against at the 5% significance level, right? So we give it 0.05, and the degree of freedom is 196. So if we compare against the test statistic, this time it's going to be true, so we can reject the null hypothesis that the beta 2 is greater than 1.3. In other words, we would say sensitivity is smaller than 1.3. Let's verify with the p-value approach. For p-value, we will use the function that calculate the cumulative distribution function for t distribution for us, which is the pt functions, and we'll provide the test statistic as the first argument, degree of freedom 196, and the lower dot tail set to be true because this time the p-value is on the shaded area of the left tail, right? So we'll just calculate it, and we do not need to multiply by 2 because it is one side, and then this time we have a p-value equals to 0.001, which is smaller than 0.5%, which is smaller than 5% significance level. In other words, we will reject the null hypothesis that the beta 2 is greater than 1.3 at 5% significance level. So in other words, we can say the sensitivity is smaller than 1.3.